My name is Ashish, and I have been working in security field since professionally since for about 3 years now, and been studying in for about 7 years. And so what my observation till now, what I have done in security, so I'll share that with you, and why secure coding is important, and not a lot of people pay attention to it. So uh, yeah. So we'll discuss about the importance of application security, what is role of secure coding in the application security is, and we'll also discuss the principles of secure coding. So what is the importance of application security? So it basically prevents the sensitive data of the users. So if let's say you have a banking application, it basically prevents the user's sensitive information and also helps to maintain the user trust, right? So if you have application that is breached, you are most probably will not sign up to that application again or will not use that application. So it also helps prevents financial losses and safeguards against legal requirements. So there are legal requirements, there are different standards. So if we consider healthcare industry, there is HIPAA standard. So if there is any kind of data breach, there is a clause that will cause financial and legal implications if you have a data breach. So and then also helps to minimize the system downtime. So if your website is hacked, no one can use it, right? Then what is the role of secure coding in application security? So application security is a huge domain. So a lot of you guys have heard about pen testing. Pen testing is just one part of the application security, which is done at the end of the software development lifecycle. So if we consider the software development lifecycle, right? So it starts from the inception, then you have your design, then implementation, and then the deployment phase, right? So the pen testing is usually done at the end of the deployment phase. So what about the previous phases? So before the deployment, you do developing, right? So in the development phase, the secure coding is where it is implemented, and there are lot of tools to ensure that the code which have been developed by the developers is secure. So these tools are called static code analysis tools. So they kind of detect what are the vulnerabilities in the software application by examining the code of the application. So basically we will consider look at the principles of secure coding. So the first one is input validation and sanitizing. So take any vulnerability, right? Let's say take an SQL injection. So consider the URI is get user $ID equal to something, right? So there we are passing an ID of a user, and the application will return the details of that particular user. So if there is no proper input validation on the ID, right? The ID, if we say ID can be a numerical thing. So if we just the user does not implement any kind of validation on the backend side, right? So I can pass any input to the application and it will return a response. It might be a error response as well or a success response as well, but it is going to impact the performance of the application as well as the security. Let's say in that the same example, we are passing the ID to an SQL query. So if there is no proper validation or input sanitization done for that particular variable, it will lead to vulnerabilities like SQL injection or excesses, right? So very simple way to fix almost 70 to 80% of the vulnerabilities is to implement proper input validation. Then the next one is output encoding, sanitization, and validation. So before getting into this, I have a question for you guys. Can anyone tell me if XSS is a client-side vulnerability or a server-side vulnerability? How many of you say client-side? Okay. How many say it's server-side? Okay. Okay, we'll get into that at the end of this. So what output encoding and sanitizing and validating is when your application processes some input or performs some function on the user's input data, or there might not be any user input data, but then again returns back to the front end, right? So that is where you need to validate and encode the outputs that are coming from the web server. Okay, so let's consider an example where I'm passing like a hello program, right? So I'm just passing a name, like my name Ashish, and the application basically returns saying that hello Ashish. Okay, so if I pass an XSS payload to it, so the server will process that and returns back to the front end, and that XSS payload is executed on the front end, right? So that is where the exploitation of that XSS happens. So how do you prevent that? You encode the whatever the input you have passed to the backend, and that backend will encode and send the data to the front end. And when you do HTML encoding on that, right, the JavaScript, your browser's JavaScript engine will not process that as JavaScript, but will treat it as a normal text, and the JavaScript payload won't be executed. Okay, so now answer to that question, the vulnerability actually lies on the server side, because the server is not encoding the output data or sanitizing the output data. The exploitation actually occurs on the client side, but the vulnerability is on the server side. Anyone clear? Yeah. Mm-hmm.
Server was not encoding the characters. The application was still encoding the characters in the front end. So they had code in the front end which encoded the characters which are received from the API. Even though in these cases when I do API testing, we usually report this as insufficient input validation.
Yep.
And not as excessive, because we have no impact. In these cases, I would say I have a bias. I would say. So there is most client side, because we can still mitigate this issue even though the server side is not encoding all the characters. It's only in the front end.
I mean, like, you can implement the fixes in the front end, but
I've seen some applications where this usually happens.
Mm-hmm.
I cannot name the client, but obviously this happens in most of the cases.
Yep. Okay.
Because it's easy. The server doesn't have to do much computation on the input, and you can do the data.
I mean, that is not like the ideal scenario on that, you should be targeting.
It's a bias.
Yeah.
I myself don't know what the exact solution is, but it works.
Yeah, but then again, like, let's say if you are using some sort of library or any sort of to like encode those characters, and the next day there is a vulnerability in that particular library, right? Then again, you have to update that library and make sure that that is not being exploitable. Yeah.
Exactly as you said. So in these applications, what happens is when I usually, let's suppose I have a delete functionality, right? So delete functionality, usually they do some pop-ups and visit the screen where they say that this element is going to be deleted and they name the element.
Yeah.
That are the cases where excesses are usually found, because they are iframes and then they are pop-ups. So the front end usually does not encode those characters. So you have to implement 2 times in front end and not just one time in the
Yeah. That's nice insight. Okay. Then the next one is authentication and password management. So authentication is basically a process of identifying a particular user and making sure that a user is a legit user, and in that the general authentication mechanisms are like a username and a password, right? There can be a lot of other mechanisms as well, like there can be private keys, RSA keys or ECC keys that you might use. Then there can be like smart cards for user authentication. The password management is basically a process of storing the passwords and enabling the users to change or modify the passwords. So So basic things that you can take care while storing the passwords is you must hash the passwords all the times, and you must also add salts to it and ensure that whatever the hashing functions that you are using, those are secure. So for example, if you're using MD5, it is not secure at all. It's like a 32 byte hash which can be brute forced pretty easily with modern hardware. And so developers usually tend to use SHA-256 or SHA-512 depending on your use case. So if it is a user passwords, normal user passwords, so you might use SHA-256 to reduce the computing because it takes a lot of computing. And if you there is some more sensitive data like card data, so they kind of tend to use higher bits, like higher size of the hashes. The next one is session management. So this is basically when you log into an application, it assigns a session to it, and which is usually ideally should be valid for a very limited time or only while you're using the application. So once you have closed the application, it should ideally log you out, but again that adds the extra from the users that they have to log into the application every time they open the application. That is where the sessions come in. So they usually have a longer expiry time, and then managing those sessions on the server side sometimes becomes difficult due to modern techniques used in authentication authorization, like JSON web tokens. So they are not stateful as compared to sessions used in your normal PHP applications, right? So managing those tokens as well is a critical thing, because invalidating those sessions can be a little bit tricky, as they are stateless, right? So the token itself contains the expiry time and the issue time as well. So when you're I'm giving you an example. So what people do in case of JWT is they create a cache database in memory, like maybe Redis or something like that, and they kind of store the invalidated JWT tokens, and they check every time if you are making a request, they will check in the cache if that particular token is present, and if that particular token is present in that invalidation database, it means that you have logged out of that application, and that JWT can no longer be used for authentication and authorization. These slides are very theoretical, so I'm not going to read all of it, but I'm just going to explain the gist of it. Then the next one is access control. So access control is basically let's say if you have 10 departments in a building, and there are 3 sensitive departments where your IT infrastructure is, and if you're a employee from the business team, then you should not have access to the IT infrastructure or those departments, right? So just access control is just maintaining a secure mechanism to ensure that the particular user has authorization to access that particular resource. So a lot of times you must have heard vulnerabilities like privilege escalation. So it is basically exploiting a flaw in the access control mechanism to gain higher privileges or more privileges than a normal user would. So in Linux or Windows, if someone has done hack the box or anything like that, you must have done a privilege escalation. That is where you exploit some vulnerability, or might be some task that is executed by a higher privileged user, which you can hijack basically. And the most important thing in the access control should be when you are developing a application, the access control mechanism should be a whitelist based and not blacklist based, right? Because you just want to allow a few users to access that particular resource. If you blacklist, that means only a few users won't be able to access it. Any other user can access it. So whitelisting is the crucial part when it comes to access control. Then the next is cryptographic practices. I hope everybody knows what cryptography is. So I will just give you an overview. So there are like two parts. One is encryption and the hashing. So encryption is basically turning the data into an unreadable format with the help of a key, which a user can use to convert it back to the readable format. In hashing, it is converted to an unreadable format, but you cannot convert back to the readable format. So in cryptography, there are like lot of things that are involved. So for example, random number generation is there, then using UIDs for user identification. So a lot of times whenever you are like developers are generating UIDs for the users, they are not using like secure random functions, which can enable an attacker to kind of predict the user IDs and enumerate and maybe potentially like chain other vulnerabilities to gain more access to the user's account. So in cryptography, you should always use secure functions, and for example, like previously I said, don't use like MD5 hashing algorithm, right? So which is not a secure one. That also like comes under like cryptographic practices. The next one is error handling and logging. A lot of times if any pen tester or bug hunter is here, so they will know like if you just add some random stuff to the input, the server will respond with some junk, right? And if you read through it, you will find a lot of good things about the application. Like you can know what kind of web server they are running, like what is the version of that web server, what if that function is using any library to process that user input. You can sometimes also see what library that is, what version that is. So in case of an error, like the server will like respond with a lot of information, and we as a developer, we don't want that to happen, right? We don't want the attackers to know what is happening inside the application, what libraries that we are using. So if they know, like let's say if I'm using an X library, right, and an attacker knows that I'm using an X library, but currently there is no vulnerability right now. But if tomorrow a library like that X library has someone finds a vulnerability, like a critical vulnerability, right, they will know that my application uses that particular library, and they can use that information to exploit my application. So that is where the error handling comes in. You should always like log the errors, whatever the errors have been, and also ensure that those error logs are not sent to the client side, and you only send some generic error messages to the client side. And in the logging, whenever you are logging any data, make sure that it doesn't contain any sensitive user information or any critical information. If like let's say if you are want to track the user activity, right, so you can just log the user IDs and kind of mask the user's personal information. So that is about the logging. Next one is data protection. So whenever you are like storing any sort of data in the database or in a bucket or any file system, right, so you want to ensure that that data is secured from the other applications running on the like same server or any unauthorized access. So that is where also access control comes in place. And there are other methods like other things like sending data through a GET request, so which is not secure. I will tell you why. So whenever we send a request to like a get method, that data can be logged through like each of the like hop in the application. So your application might contain a load balancer, then you might have a reverse proxy, and then you might have the actual application that is running. So this is very complicated, like infrastructure can be there. And if you are sending data through a get request, it will be logged at each hop in the chain, because they usually are used for some like performance monitoring, or ensuring that what are the endpoints that we are using, what data, it is it is usually logged. So you should always send any sensitive data in post request only. uh, then the next one is communication security. So this is regarding how your application talks to other services or the front end or any other application, or that likewise. So whenever you are sending like any data from one application to the other application, you have to ensure that the channel that you are using is encrypted and secure. So for example, in case of web application, most of the times TLS is used. uh, in case of some let's say if you are using any web sockets, right? So in the web sockets you might not have a TLS uh, like that can fit your need properly. Then you can use a custom encryption layer in the application and the front end that can encrypt the data that is going back and forth through the application. uh, in many of the banking applications, what I have seen is what they do is, even if they are using like TLS, they will have another encryption layer for like very sensitive endpoints. For example, if you are get processing in a card transaction, that is where whatever like if you are giving any your card details, that card details will be encrypted and then sent to the web application web server over the TLS. So that is also an additional layer of security in case if someone is performing man in the middle attacks. In that case also, the user is kind of secure because the data is already encrypted. uh, the next one is application and system configurations. So this is mostly around the environment and the application, around the application and its configuration. So let's say if I have an application that is running on port 443, then i I have to make sure that only that port is accessible over the public IPs, and not like the other ports as well. So, and also like in case of secure coding, you will need a lot of passwords, like passwords for databases, passwords for some other services, like if you're using S3 buckets, for example, or like if you're using JWT, you will have your secret key to sign those JWTs. So in that case, you should never hard code the any secrets or credentials. You should always use a vault which stores all these keys, and you can access that, get those keys from the vault. The reason being is like let's say in the vault you will always have like multiple users that can access the vault and read the credentials or sensitive information, and you can use that for like logging and monitoring and keeping track of who is accessing or changing the secrets. And if you have applications, you can also like keep a track of which application should have access to which secret. You can granularly control those accesses. Uh, then the next one is database security. So a lot of these days, a lot of companies are transitioning to the cloud. So kind of makes it less relevant. But even when you're having a local database stores, right? So in that case, if your data is very sensitive, always ensure that the whole database has encryption enabled, and also segregate the users in the database and properly assign the roles and accesses for particular database. So like if you have one database server, it will have like multiple databases, and not all users will access need to all the databases, and not all the applications will need access to all the databases. So you have you can granularly control the access and ensure that you are not providing too many uh, too over access to any of the application or any user. Next one is file management. So a lot of you guys must have like learned about the file upload vulnerabilities, or execute shell execution through file upload, right? So what file management like a secure in terms of secure coding means is you whenever you are like uploading a file, you ensure that you have a safe directory to store those files, and ensure that there is no path traverser vulnerability to upload the file to a different directory, and also change the permissions of that particular file directory to like read and write only, so that even if someone uploads a malicious code, they won't be able to execute that particular code. And always ensure that whatever the file that is you are expecting is validated. So let's say if I have a function where a user can upload a profile picture, right? There should be a check where I can see that if the user has uploaded a picture and JPEG or PNG or any picture format, and not the actual like any other file as well. So like for example, in terms of like pictures, right, you can use magic bytes, which are like the first 4 bytes of a file, which you can use to check what kind of file it is, and also check the extension of the file to ensure that they are not just putting first 4 random bytes as magic bytes and then having the rest is a malicious code. Next one is memory management. So this is like very specific to some languages. It not applicable to the languages which are memory safe. So for example, if you consider like C or C++, so they have ability to manipulate memory of the application. You can use pointers, and so like a lot of times what happens is you can a lot of people, what they do is if they want to get an input from the user, they will just use gets function in C to get the user input, and not have to worry about what is the length of the input, and what is the input that the user is passing, right? And so what happens is in these scenarios, an vulnerability called buffer overflow is has anyone heard about it? Yeah. So what happens is if you are not managing the memory properly, like if you are not allocating proper memory sizes, or you are not freeing the memory after the use, it can lead to like buffer overflows or memory leakage, all those things, right? So in that case, like there are a few functions that are like vulnerable to like vulnerable all the time, you can say. So like strcat or strcpy, so which is used to copy data from one string to the other string. But what it doesn't do is check the size of the target and the source, and it will overflow into the memory of the application, which can be exploited in many ways. So this is specific to very few languages, like a lot of languages like for Golang, Java, they have garbage collectors. That means whenever like the variable goes out of the scope, it will free that memory and null it out. So in case of C++, it doesn't happen. So you have to manually add those free functions and free those memory from the application. Yeah, that's it. Any questions? What is a CWE? Anyone?
Hi.
Hey.
Do you have any specific advice or inputs when managing the SaaS platform, right? Software as a service. It could be multiply uploading on that platform from a client side or user side. Like, what are the specific advice that you
For the whole platform, right?
So, for the multiplayer upload from
You're uploading a file. Okay. Okay. In terms of like file uploads, what you can check is if there is any sort of expected data, like the data type you are expecting. Like let's say if you said that you are expecting a video, right? So what you can do is check if the file uploaded is actually a video. You can do it by like multiple methods. One is like checking the extension, but that is not like a whole in itself. You can also check for the magic bytes, which are like the first 4 bytes of a file, which specifies what kind of file it is. So for example, even if you if you go in like Linux, it like if you don't give any file extensions, it doesn't matter to it, because what Linux does, like most of the applications in Linux do is, right, they check the first 4 bytes of the file and see that, if it is a media player and it says the first 4 magic bytes are saying that it is a video file, then that media player will play that file. And if it is like if you pass a PDF to it without any extension, it will check the first 4 bytes, and if those are not like for video, it will not process the rest of the file. Okay. CWE. So CWE stands for Common Weakness Enumeration. So this is an initiative by MITRE. So if you go to like the software development view, you will find lots of like different classes for vulnerabilities, and which are related to software development, and which can be addressed in the development lifecycle itself. So like for example, let's say API function errors, right? And okay, so this is a weakness that can be introduced in an application. So use of inherently dangerous functions, right? So this is a weakness that can be introduced in the application, and it has an ID of 242. So this website basically gives you a list of all the weaknesses, that not like all the weaknesses, but a lot of them, that you can see and learn through what can be the possible dangerous coding practices can be there, like what you can like avoid coding, right? So here use of inherently dangerous functions, right? So we learned that strcpy is not a good function. It is a dangerous function because it can lead to like buffer overflow or memory leaks. uh, so this if you find a vulnerability where someone is using like these kinds of function, like if you see a CVE, there will be CWE for that particular CVE as well, which will tell you what kind of weaknesses that are there in that particular CVE. So I would highly suggest you to read through this. It is a bit too much for like, but yeah. So as you start learning about security and more things in like software development, I would this is a great source to learn about the vulnerabilities, and how like there are examples, and you can also go and see how to fix them as well. So what I have seen is, a lot of people say if you are doing like going security, you don't need to know coding that well, right? But that's like not true at all. So always try to learn a bit coding, at least one language. A lot of will suggest Python because it's the easiest. So My advice for the students here will be to go and develop a web application, do a pen test on that application, and try to see what kind of vulnerabilities you are able to find, and then go and fix those vulnerabilities. That way you will understand, what how the application is working, what are the vulnerabilities are, because once you get that, and you start doing the actual pen test, and if you just give one bad input to the application, and if you see the response of the server, then you will know that what how the backend is working. And sometimes if everything is done properly, you will see proper outputs from the server, and maybe you won't waste that much time on that particular endpoint, right? So understanding how the backend is actually working, what kind of functions it might be calling internally, is a really good way to find different kind of vulnerabilities. Yeah, thank you everyone.